going with 6-1, so there's still more to cover in 6-1. Let me see what's going on with my camera for a second. See if everything's kind of still working pretty well. Okay, so actually let me exit out. Let's go through a sorry, it's taking a little bit of time to load. Kind of move this guy off to the side here, and then let's bring up the cheat sheet really quick. All right, so the next next thing we're going to talk about is the exterior angles theorem. So with the exterior angles theorem, the exterior, so we're going to use we're going to go over the exterior angles theorem. And I know it's a little hard to see. Let me see if I can try to move it just a tad bit. Let's take a look at the left-hand side for the image. We have a triangle that's ABC, and we're saying that if you add the if you look at the angle that is exterior to the triangle, like this angle right here, we're saying that if you add A and B together, then it should equal 1. So why does that work? So let's just draw over here that same thing, but let's give it some numbers. You can think of any numbers that you want, right? So let's say this is C, this is B, this is A. Let's connect these points together here. And let's say this is angle, or let's actually give this an angle, or let's see. How should I say this? So let's come up with two different angles here. Just come up with two different numbers. So I'm going to say that this is about 30 degrees. This is about 100 degrees. And then they have to add up to 180 degrees. Okay, so 130 degrees. So this is going to be 50 degrees. Okay. So what the exterior angles theorem is saying is the angle on the outside here is going to be equal to the angles not right next to it, but are opposite away, very far away from that angle. Okay, the two angles that are farthest away. Okay, so we're going to say that angle A plus the measure of angle B should equal the measure of angle 1. Let's see if that's true. So we know that the measure of angle A is about 30 degrees, I said, and the measure of angle B is about 100 degrees. And then we're saying that's 130 degrees is equal to the measure of angle 1. But let's see. So how you can verify this is very easy. So sorry, this is the measure of angle 1 right here. So this is the measure of angle 1, okay? And let's say that since we know that measure of angle ACB, let's say the measure of angle ACB, and let's have a look here. They're on a straight line, the measure of angle 1 and the measure of ACB. If we add the measure of angle 1 and the measure of angle ACB together, this little angle plus this outer angle, because it's on a straight line, we know that they are supplementary to each other. That means these two angles should add up to 180 degrees. So let's put in the value of ACB. Let's substitute that in with the actual known value. That's 50 degrees. And then let's add the measure of angle 1. That's equal to 180 degrees. Plus this plus the measure of angle 1 is equal to 180 degrees. Let's subtract 50 degrees to find out just what is the measure of angle 1. And you find out that it's 130 degrees. Well, look at that. We figured out from the supplementary angles on a straight line that by virtue of the supplementary angles theorem, measure of angle 1 should be equal to 130 degrees. And look at here. In our statement before, we said that if we add a measure of angle A and B, which are farthest away from the exterior angle A and B, 130 degrees, it should add up to 130 degrees. And if you look here and here, they are the same thing, or they are equivalent. The measure of angle A plus the measure of angle B is indeed equal to the measure of angle 1, because we found out the measure of angle 1 is 130 degrees. You can do that with any triangle that we want. Let's try this. Let's try another vertical triangle. Okay, so let's say this is an equilateral triangle, meaning all the angles on the inside have to be the same. Okay, and then let's call the exterior angle 1. We'll call the exterior angle is 1. This is A, B to C. Okay, and we have to say the measure of angle A plus the measure of angle B plus the measure of angle C is half. That has to equal 180 degrees, right? And let's say that because they're equilateral, they have to be equal to the same thing, right? So we could say that the measure of angle A plus the measure of angle B plus the measure of angle C, I'm sorry, they're all equal to each other. Let's say that the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C. It's an equilateral triangle, meaning each of the sides are the same. Their angles will also be the same as well. We're trying to solve for the measure of the exterior angle here on the outside, which is the measure of angle 1. Okay, so if we know that the measure of angle A is equal to the measure of angle B is equal to the measure of angle C, couldn't we say that the measure of angle A, you could replace the value of measure of angle B with measure of angle A? Sorry to make this complicated, but it's just you have to kind of get used to this. This is all math that you know, but it's written a little bit more in a complex way to kind of like where you tilt your head and you're like, huh? What? I know that already, but why does it sound difficult? You want to see it in a more rigorous way, written in a more in tougher and complex situations. So in the future, when you're used to doing this sort of exercise where you have to put complexity and thoroughness, right, and what we call clarity and articulation, like this is a really nice, extensive way and very academic way and very clear way for all mathematicians to understand what you're doing. You have to be able to see information written in different ways. So anyways, I digress. I went off the rails and went too far into something else. Let's go back to this. Measure of angle A is measure of angle A. I want all of these guys to be in the same angle. And I can do that because I know that the measure of angle B, this is an equilateral triangle, is equal to the measure of angle A. And the measure of angle C, in place of the measure of angle C, I can actually put in the measure of angle A because I know that they're equal to each other. It just makes it easier to solve for one angle because right now it looks like there's 3 unknown angles. And if you rewrite everything in 3 different, or like three identical angles, you could say that the measure of angle A plus another measure of angle A plus another angle measure A, you have 3 measures of angles A. So that means what that says is if I multiply the measure of angle A 3 times and I set it equal to 180 degrees, that means 3 times whatever the measure of angle A is equal to 180 degrees. But I'm here to figure out what just one of the measure of angle A's is. That is 60 degrees. Oh, I'm sorry. Measure of angle A is equal to 60 degrees. Okay, and like I said before, measure of angle A is equal to measure of angle B, which is measure of angle C. That means that is also equal to the measure of angle B. And that is also equal to the measure of angle C. Okay, I did all that work, but sorry to kind of make this more complicated than it should be, but I'm looking for the measure of angle 1, the exterior angle. And we said before the exterior angle, the exterior angle has to be equal to the 2 opposite angles very far from it added together. Let's see if that's true. The measure of angle A plus the measure of angle B. Well, we found out the measure of angle A is 60 degrees, and it's equal to the measure of angle B. So in place of measure of angle A, I can put 60 degrees plus 60 degrees because they're both equal to 60 degrees, and you add them up, that's 120 degrees. But now you're saying that with this, measure of angle A plus B is equal to 120 degrees. Is it actually equal to the measure of angle 1? Well, let's see. Okay, so we also know that the measure of angle C plus this little inner angle here plus this outer angle, because they're on the straight line, we know that they have to add up to 180 degrees. They're supplementary angles. They're on one singular line, which makes 180 degrees. And we just found out that the measure of, or actually, let's just say we don't know. We still don't know what that measure of angle 1 is, but we do know that a measure of angle C, I found out, was 60 degrees over here. Okay, over in this work up here. So let's substitute in just what we know from before, 60 degrees plus the measure of angle 1. let's assume that we don't know what the measure of angle 1 is. I subtract 60 degrees from both sides. And looky here, the measure of angle 1 is 120 degrees. Up here, that's the exterior angle. Up here, though, I only figured out that the measure of angle A plus B, which is 60 degrees plus 60 degrees, is 120 degrees. That's good. And then I just found out down here that the measure of angle 1 is equal to 120 degrees. So guess what? This totally verifies the exterior angles theorem, where the exterior angle, which was angle 1 up here, is equal to the interior angles, the opposite interior angles, measures of angle A and B. Okay, so that's not even a problem. That's just, I just showed you the theory behind this. Okay, so now let's actually work on some problems here so I can help you out. Okay, all right, so let's work on a problem now using the exterior angles theorem. And now I can kind of put this away, full screen this, if it will allow me to, and then I'm going to continue writing here as that loads up. I don't know what's going on here. So let's use this theorem to solve some problems. Oh dear, what's going on here? Okay, so let's do a problem now. Let's try a problem. Okay, so let's draw a line here, straight line. Let's say that this point is J, and then over here is M, a little bit further on the right of the line, and then in between J and M, not right in between, but somewhere in between J and M is a point K. Let's draw another point L out here, and let's draw this line here to here. Let's say that this is X degrees. This is a angle value, so whatever X is, degree sign, but I don't know what it is. This in here is 50 degrees, and this out here is 2x minus 15. All of that is degrees. So that'd be kind of mean. It's like, hey, how big is that angle? Instead of just saying, oh, I think it's about 120 degrees, you're like, that's 2x minus 15. What? Then what's x? Well, that's what we're here to find out. Okay, so we're going to find the measure of angle J to K to L. Where's J to K to L? J to K to L. So we want this angle measure right here. In order to find out the number for the angle measure in here, we're going to have to find out what x is first. All right? But what's the exterior angles theorem say? What does it say? It says that the exterior angle, which I see the triangle here, that means the angle that is exterior to this triangle is indeed JKL. So the measure of angle JKL should be equal to the, by the definition of the exterior angles theorem, it should be equal to the two interior angles of the triangle that are away from it. It's not this one. This is an interior angle that's right next to my exterior angle. So that, I don't include that, but I can say that this angle and this angle that are very far away from it, the farthest angles away from it, farthest away from the exterior angles, if you add these two together, so this is L and M, they should be equal to the exterior angle. So this would be equal to the measure of L plus the measure of angle M together. So let's go ahead and substitute these things. The measure of angle JKL is 2x minus 15 degrees. 2x minus 15. And we'll say that's in degrees, right? And then that is equal to the measure of angle L, which is x degrees, plus the one known value, which is 50 degrees. 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 50 deg Okay, so this is going to be like regular algebra. We want to just isolate one x value to see what one singular value of x is going to look like. And I can do that because I said that the exterior angle out here is equal to these two angles out here, and I set it equal to each other. So now we can just solve for a singular value of x. First thing I'm going to do is I'm going to combine I'm going to get rid of the constant numbers, okay, and just put it to one side. So I suggest that you put it maybe to the right, or else if you subtract 50 from both sides, you'll end up getting a negative number here, and it's going to get real ugly. But you can do that too, whatever way works for you. Okay, so I have 2x is equal to x plus 65. I will subtract x from both sides, and 2x minus 1x is equal to a singular value of x. That should give me that x is equal to 65 degrees. Is that the answer? Is that what it's asking for? Does it tell you to ask for x? No, I'm asking what the value of this angle measure out here, this exterior angle, is. It's 2x minus 15. I have a value of x. So I'm going to go back over here and say the measure of angle JKL is equal to 2x minus 15 degrees. Right? And then I'm going to plug in what I got from my x value in the previous work. That's 2 times 65 minus 15. That is about 130 minus 15, and that is equal to 115 degrees. Okay, so that is the measure of angle JKL. Okay, all right. Why don't we try this one down here? I got another problem. Let's draw a line going this way. Let me see if I can zoom out and try this one here, down here. Let's do a right angle here. Sorry, as best right angle as I can get. And then let's do it from here to here. This is the exterior angle will be 123 degrees. In here is 90 degrees, or a right angle. And then in here is angle number 4. We need to find out the measure of angle 4. Okay? Well, I know that the exterior angle, that's an exterior angle that's outside of the triangle, is equal to the two opposite interior angles. I got this one, and I got this one. So it's pretty simple. I could say that the measure of this 123 degree angle is equal to whatever this guy is and this guy is. So this guy, if it's a right angle, then that indicates to you that that's 90 degrees. The measure of angle 4, however, is the one that we're trying to solve for. Simply put, you subtract 90 degrees from both sides, then you should get that the answer is approximately 33 degrees. It's equal to the measure of angle 4. Okay, that was a quick one. I'm going to give you one more to try. Oh, sorry about that. Kind of knocked over my stuff there. Right. Give you one more problem to try on your own. You can pause it, and then you can unpause it to see the solution. Okay, let's do a straight line. Point out here, point right here, and a point right here. Let's connect those. Looks like an equilateral triangle, but don't ever assume anything unless I tell you that's an equilateral triangle. This is angle 1, 2, 3, and then 1 is equal to 37 degrees. Angle 2 is equal to 3x plus 47 degrees. Measure of angle 3 is 5x plus 62 degrees. And then this big angle here is worth, let me see if that tells you what to do. Sorry, give me 1 second. I gotta make sure that I wrote this problem down correctly. So you can fast forward this part until I figure out if I wrote down the problem correctly. I just gotta make sure. Just want to see if there's a problem in here that has this. Okay. Alright, doesn't look like it, so I just don't know what information they gave you, but let's say that this outer angle is 90.75 degrees. Okay, that's the only thing that's given to you. Capiche? Okay, so I mean, there's a few things that you could do to find this. You could either set angle 1 plus 2 plus 3 is equal to 180, the triangle sum theorem, or you can do the exterior angle theorem, which is 96.75 degrees is equal to the measure of angle 1 plus the measure of angle 2. That would give me 96.75 is equal to 37 degrees out here. And then this is 3x plus 47. So let's subtract 47. Oh, I'm sorry. Let's not do that. And then let's add the 47 and the 37 together. So that would give me 80, I believe. 96.75 degrees is equal to 30. I'm sorry, that would be 80 degrees. 37 plus 47 is 80 degrees. This is 96.75 degrees plus 3x. Let's subtract 80 from both sides. That would give me 16.75 degrees is equal to 3x. So 3 times x is equal to 16.75, but we want to find the singular value for x. Let's see, I believe if you do that, you get about 4.25, if I'm not mistaken. Let's see. Sorry guys, I'm taping this kind of late, so I'm a little bit lazy right now to solve for the simple math. 16.75 divided by 3. I just got to make sure that's correct. 5.8. So it's going to be a little bit messy, these numbers here. Okay, we can deal with this. So, let's see, 37. Okie dokie. So, okay, so that's going to be 5.83 repeating is equal to x. All right, and then whatever x is here, so we're trying to find the measure of angle 2. So we know that's the measure of angle 2 is equal to 3 times x plus 47, and I just found out that x is equal to 5.83 repeating plus 47, and then we know that that should be 16.75 plus 47. That should give me about 63.75 degrees. Okay, and then over here, measure of angle 3 is equal to 5 times x plus 62 degrees. So that's 5 times 5.83 repeating plus 62. 5 times 5.83. So I'm sorry I used some kind of odd numbers here. I don't think it was intentional. 5.83 times 5 is about 29.15. So let's go back to the document cam. Okay, so I got about 29.15 plus 62. That should give me about 91.15 degrees. Okay, so let's take a look here. Let me see if I do that correctly. Like I'm goofing up something here, but okay. Yep. Yeah, okay, I did that right. Okay, so ideally, if we did everything correctly, we know the interior angle sum theorem right here, or the angle sum theorem of triangles. We know that measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Let's see if this is true. Well, we found out that, or we know that the measure of angle 1 is 37 degrees from up here. We don't use x, so just remember this. X, we solved for x, but that only helped us to find measure of angle 2 and the measure of angle 3, okay, because they actually had a weird angle measure that included x. Measure of angle 1 does not include anything with x, so you just write that as 37 degrees, okay, so don't make that mistake by putting x in here. Okay, it's not. The measure of angle 2 is 63.75 degrees. And the measure of angle 3 is 91.15 degrees. Let me do that one more time. Sorry, guys. Just got to make sure that 16.75 is divided by 3 is what it is. 16.75 divided by 3 is... I have to make sure... Sorry about that. I'm talking in a weird way. Oh, come on, deal. Oh boy, this is real laggy. Come on. Alright. Give me 1 second, guys. I don't know what's going on with the computer. On my end, it's like really glitchy right now. Okay, so you know what? Let's just see if this adds up. Come on. Sorry about this, guys. I don't know if you guys are seeing this, but on my computer, it's just super frozen right now. Come on. This is getting really... Okay, so it's... Oh, shoot. So it looks like it's 5.583, so... Whoops. Okay, so I do apologize. It's 5.583. So let's fix that. Don't worry about this. This is still the same. This is not inaccurate. This is 5.583 times 3. Don't worry. This is still going to be the same, 63.75. Okay? But however, this might be different. This is 5 times 5.83. So, I'm sorry about that, guys. Well, math is quite complicated. Times 5. 27.916. Oh dear. 27 point. Okay, so where are we at right now? So this is so this is 29.56. 27.917. 27.91. We'll round up to 7 here. Plus 62. I believe that should be 90. 89.917 degrees. This is not fun. I'm sorry about this, guys. I don't even know if this math is correct anymore, but I think I just fudged up the numbers before I started this problem, but hopefully you get the idea. This is just to check to see if I did it right, so I don't think it's worth all this effort, because I think I just gave you a problem that didn't have very clean numbers. Okay. 89. 17. Or 89. 917 plus 63.75 plus 37. Hopefully it comes out around. Okay, I think I did something wrong. Okay, so I do apologize, but hopefully you guys got... So forget this. I just trust that the method that I told you before you started checking for this thing here. I think I just messed up somewhere. And I think I messed up in one of these calculations. But the method I showed you is correct, okay? In setting up that these two should be equal to 96.75. I think it's just the way I set up this problem. The numbers didn't work out cleanly because I didn't set it up very well. Okay, guys. Well, we're going to stop right there because I'm pretty much done. Okay. Thank you, guys. Bye.